In this video, we are going to be looking at test and exam type questions for exponents. And look in the description, grade 9s, there you will see a link to the workbook. So all the questions that we'll be doing, you can print that out, try it on your own first maybe, and then use this video as your memo. Okay, let's get going. So if we look at the first question, straightforward. We've got x to the power of -2, and then that is raised to the power of 3. So just using our law of exponent, that would be x to the power of -6 if we multiply those two exponents. We don't want our answers with negative exponents though, so let's just go ahead and make that exponent positive. So it will become, you reciprocate that one, and it will become 1 over x to the power of 6. If that seems strange to you, how I got from there to there, you need to recap dealing with negative exponents. How can we also look at this? Where does this law come from? Well, it's x to the power of -2 that is being multiplied by itself 3 times. And that will get us the same answer because we just add those exponents, right? Just using a different law of exponents. And then obviously we need to make the exponent positive. Same story, it will get us to that answer. Okay, second one. Over here, this is slightly different than the previous question because the previous question just had our x to the power of -2. But with this one, we have to consider that there is a coefficient as well. Now we need to multiply the exponent on the outside by all exponents on the inside. What I see students do, grade 9s, is let's say they've got 2x to the power of 2 raised to the power of 3. What I see students do is they multiply the exponent on the outside by the base. We're not going to multiply the exponent by the base. We only multiply the exponents on the outside by exponents on the inside. All right, very important. So over here, we're going to land up with 2 to the power of 4 and then x to the power of 6. And then we're not quite done because we can evaluate that. 2 to the power of 4 will be 16. You don't need your calculator for that. And that will become, or that stays, x to the power of 6. Third question. All right, well, if we look at that, we've got a base of P and a base of Q. They're not the same. So there isn't much that we can do there in order to simplify. But what we need to deal with is that negative exponent. We need to give our answer with positive exponents. Common mistake that I see students make, they would do this. Was this your gut instinct as well? Or what you would have tried? They flip the whole fraction to make that exponent positive. But remember, that exponent of base Q is already positive, so that's not going to go anywhere. There's just a coefficient of 1. It needs to stay where it is because it's got a positive exponent, and then this one will have to move down in order to make that exponent positive as well. And there we go. Again, go back and look at negative exponents if this feels a little bit strange to you. Let me know in the comments if that's you, then we can make a video on this. All right, let's investigate. So we've got 6 that is being multiplied with P plus Q to the power of 0. Well, anything to the power of 0 will just give us 1. So this whole bracket is to the power of 0. So we can definitely say that it's 6 times 1 because that whole thing will just become 1. And then your final answer would be 6. Everything is being multiplied. So there's one term. Everything is being multiplied, so we can use our laws of exponents. Let's go look for some similar bases. We've got a base of P, P, and P, and Q, and Q, and Q. The law of exponents, when our bases are the same and we are multiplying, we can add our exponents. And remember, we have those exponents of 1. That's what it means. We can go ahead and multiply these numbers together. They're just being multiplied. There's an imaginary 1 there. So that will give us 12. And then base of P will be 2 plus 1 more. It will be P to the power of 4. And then Q to the power of 1 plus 3, which is 4. Take 1 away to the power of 3. And that's it. We simplified it. F. Now we're dealing with a fraction. And if we look at the denominator, there's not much that we can do. There's actually nothing we can do there to simplify at the moment. It is its simplest form. So let's look at the numerator and see what's going on over there. Well, everything is being multiplied. So let's look for some similar bases. We've got base of x and of y. When our bases are the same and we are multiplying, we can add the exponent. So that will become x to the power of 6 times y to the power of 5. Okay, so we simplified the numerator. Now we can simplify further. So we've got a fraction. So it means that they're being divided, right? So what does the law of exponents say? When our bases are the same and we are dividing, we are going to subtract the exponents. We're going to do this one in 2 different ways because I see students doing it in these different ways. I prefer this way because that I'm going to do first, because I find that's when students don't mess it up when they're dealing with negative exponents, but whatever works for you. So when my bases are the same, x, 6, subtract 8, top minus bottom, times top minus bottom. That will give me x to the power of negative 2 times y to the power of 2. We need to deal with that negative exponent. X is the only base that has a negative exponent, so that one stays where it is, and that one will move down. We'll reciprocate that, and there is our final answer. Or what some of you might do, or how you would make sense of this, is that you could say, okay, but wait a minute, for my base of x, I've got x to the power of 8 in the denominator. So what that would mean is that at the top, x is being multiplied by itself 6 times, and in the denominator, it is being multiplied by itself 8 times. So that cancels out, gives 1. So in the denominator, we'll be left with 2x's, which is x squared. So I've heard students say that if the bigger exponent is in the denominator, then that is where I will put my x. And then at the top is where I have the bigger denominator for y, and that is where I will put my y that is being squared. Now note we get to exactly the same answer. So however you look at this, perfectly fine, just as long as it makes sense to you. Okay, for G, we need to be mindful there that we've got that coefficient over there. What I see students do is that they would multiply the negative 3 and the 2 to get that. And then they would, I guess, put that whole thing to the power of 3, something like that. We can't do that. This over here, that exponent where this bracket is raised to the power of 3 only applies to that. So we're just going to wait a little bit with that. We've got the negative 3 that is being multiplied with the rest of that sum. So let's just deal with that one. Exponent on the inside gets multiplied with exponent. Don't multiply the exponent and the base. So that's going to land up being 2 to the power of 3 and 8 to the power of 9. In the next step, we can just simplify that. 2 to the power of 3 will be 8. And now we can multiply that to get to negative 24, 8 to the power of 9. Just showing you're working step by step. Last one for this question. So don't be freaked out when there seems to be a lot going on. Just step by step, use your laws. For the denominator, let's just leave that like that for now. So the moment, grade 9s, when you see a negative exponent, don't feel like you immediately have to make it positive. We just need to make the exponents in the answer positive. So just leave that like that for now. All right. We're going to have to deal with that bracket that's raised to the power of 3. So all the exponents on the inside gets multiplied with the exponent on the outside. But now, be mindful, this is a common mistake. That is a negative 2. So I am going to keep that negative 2. That belongs together. That whole thing is going to be to the power of 3. How can we also look at that? Well, it's negative 2 inside the bracket that will be multiplied by itself 3 times. So that's why I need to keep that negative inside the bracket with the 2. All right, that will become a to the power of 6, b to the power of negative 9, and then multiply there's that second part, a squared times b. So there's the first step of showing our working out. Second step, well, let's deal with that negative 2 to the power of 3. So that would be -8, just thinking about our integers there. We can also put these together. We've got some bases that are the same and we are multiplying at the top. So that would give us a to the power of 8 because we're adding those exponents, and -9, and we add, oopsie, that should be a 5 there. Sorry, I'm sure you saw that. So that would be -9 plus 5, that would be -4. Tongue twister. Okay, so far so good. Show your steps. Don't feel like you need to go straight to the answer. Okay, so far so good. We've got some similar bases again, but now we are dividing. So when we are dividing and our bases are the same, we are going to subtract those exponents. And then, of course, this will just be a -8 divided by 2, which will give us -4. -4, I am going to use the way that works for me. You do what works for you. My bases are the same, the base stays the same, and I subtract my exponents. There's for A, for base B, -4, and I take away a number that is already negative. So that is crucial. All right, so then I'm going to land up with a -4. A to the power of 1, so I don't have to write that, and that will become times B to the power of, that will become -4 plus 5, which will just become 1 as well. So that will be our final answer. Make sure that you logically show your steps and you're working out with the sum that gets a little bit more complicated and longer. Okay, head over to the next practice question.